All right. Hi, everybody. This is going to be the great experiment. Just try to get everything kind of set up. Actually, if I move it up a little bit farther. Okay, so we're going to be looking at trigonometric identities. And in this first lesson, as you can see, it's still March 16th here. Just kind of going through and simplifying some trig expressions. So I kind of want to review a little bit about what we were doing before. So we had these reciprocal identities. And those identities were that, say, the sine of theta was 1 over the cosecant of theta. The cosecant of theta was 1 over the sine. And so on, right? Just kind of write all these down to refresh. So cosine is 1 over the secant. And secant's 1 over the cosine. Remember the other two? And the other two were tangent was 1 over cotangent. And cotangent was 1 over tangent. Okay, so in one way or another, we are interested still in using these reciprocal identities. A lot of the time, what we're going to try to do in this section is get everything in terms of sine and cosine and see what simplifies. Now, that's not always going to be what we're going to do, but for this section, that's kind of what we're trying to do, as I'll explain here in a bit. Okay, so kind of seeing how far over I can go here, I think I'm about right here, which means that I should be able to write also our Pythagorean identities that we talked about. Okay, Pythagorean identities, and those were the three really important ones. Sine squared theta plus cosine squared theta was 1. 1 plus tangent squared theta was equal to secant squared theta. And 1 plus cotangent squared was equal to cosecant squared. Okay, so that we did before, and you should have it in your notes somewhere. It's really important. Okay. There are some other identities that I want to give to you. So these are the two sets that we talked about before. You got to know those really well. We also have these quotient identities. I call quotient identities. And that is that the tangent of theta. Okay, I'll write this down, then we'll try to explain. So tangent of theta is actually equal to the sine of theta divided by the cosine. That is a thing. If we think about it in terms of sine was, say, y over r, and if I divide that by cosine, which was x over r, notice that if I multiply by the reciprocal there, I get y over x, and remember that was our tangent. So we can actually go through and show that the way we've defined our tangent and sine and cosine, that tangent is sine over cosine. Okay. Analogously, we also have this really important identity. Cotangent of theta is cosine over the sine. Okay, so both of these two identities are going to be used, quite a bit in trigonometry and calculus, so that they're kind of on equal par with the Pythagorean identities over there. There's kind of a final set, and I'm just going to write these down, honestly, just not mention too much about them due to having to cut some stuff out, not do everything, okay, that we would normally do. But let me just kind of mention these real quick. These are called negative angle identities. So the idea is if I do the sine of negative theta, if I do the cosine of negative theta, what is that equal to? Okay, so that's the idea behind a negative angle identity. So for instance, the sine of negative theta, that is equal to negative sine theta. So if I was doing something like the sine of, say, negative pi over 3, that's equal to negative sine of pi over 3. Okay, so we're kind of using that symmetry of our unit circle in there. This also means that we have an odd function. Sine is an odd function. Okay, 2, cosine of negative theta is equal to cosine of theta. So cosine's even. Likewise, if I do like cosine of negative pi over 4, that's going to be cosine of pi over 4. Okay, let me just write the other ones down. Tangent negative theta is negative tan theta. Okay, cosecant negative theta is negative cosecant theta. Secant is also even. So cosine and secant are the two even ones. The other ones are going to be odd. So secant of negative theta is secant theta. And we have the cotangent of negative theta is negative cotangent. Okay, so negative angle identities. May use them occasionally. Not as important as the other ones. Okay, so what do we want to do? Here's our directions. Okay, so it says write each in terms of sine and cosine. Then simplify. Simplify so that there is not a quotient. So basically we're saying we don't want a fraction. We want to write everything in terms of sine and cosine, simplify, and then see what happens. That's the idea. Okay, so let's show some easy ones. So, and this is in section 5.1. We're really just doing what we need to do from 5.1 and nothing more. Okay, so this is number 53. Cotangent theta times sine theta. Right, so the idea here is if I were to rewrite cotangent, so I want to try to rewrite everything in terms of sine and cosine. Obviously, this term's already sine, so I don't have to worry about that. I can rewrite cotangent theta as cosine of theta over sine theta. I don't want to use cotangent as 1 over tangent because that's not rewriting in terms of sine and cosine. So I'm going to rewrite cotangent theta in terms of cosine theta over sine theta. That was our quotient identity, right? So I'm basically just taking this cotangent and rewriting it as cosine over sine. And then what's going to happen? Oh, I'll use our Easter color since it's Easter, right? And these signs cancel, and this is just cosine. Oh. So that is cosine. There. Okay, let's look at another one. And at any time, if you want to try these before we write them out, feel free to just pause the video. Okay, so 54. Secant theta, cotangent theta, sine theta, right? And for this one, we want to write everything in terms of sine and cosine and simplify. So secant, you may note that we could write that as 1 over cosine. So now when I'm using our reciprocal identity, cotangent is cosine over sine, and the sine is still right there. Okay, so what's going to happen here? Well, you may note that I've rewritten everything. Here I use the quotient identity. Again, I want to use that because it's getting everything in terms of sine and cosine. Here, to get secant in terms of cosine, I just do 1 over cosine, use the reciprocal identity. And then what cancels? So this cosine over cosine cancels. Sine over sine cancels, and I just get 1. So that whole thing is 1. Kind of cool, right? Okay, let's look at some more. So this is 56. Okay, kind of keep in mind that, well, I guess I can leave our directions up here. Let's look at 56. So we have, cotangent squared theta times 1 plus tangent squared theta. What I do want you to keep in mind is that there's usually more than one way to do these. Typically 2, 3, 4 ways. There might be an easier way, but that easier way might not be obvious at first. And if it's not, that's completely fine. As long as you're doing your steps, going through, that's what we're after. In the end, you're going to get it. Okay? So, for this one, if I just strictly play by the rules, and I write everything in terms of, say, sine and cosine, initially, this is what I could do. So cotangent is cosine over sine, right? So if I do cotangent squared, that's actually cosine squared over sine squared. So I can take this guy. It would be cosine squared over sine squared. And over here, the tangent was sine over cosine. So tangent squared is going to be sine squared over cosine squared. Okay? And then what you could do is distribute. So I could distribute this guy. And I could distribute this guy and see what we get. So cosine squared over sine squared times this, that's cosine squared over sine squared. And then this times this is cosine squared over sine squared times sine squared over cosine squared. Okay, so it looks like a hot mess. It's actually not so bad, okay? I think I got everything on the screen there. Yep, okay. So the cosine squared over sine squared, that is cotangent squared, right? That we had originally. And this one is the sine squareds cancel and the cosine squared cancel. So what's left there? That's actually just a 1, right? Instead of rewriting in terms of sine and cosine, I could have gotten that by distributing and rewriting kind of another way. But right now, we're just kind of doing what they tell us to do. Rewrite in terms of sine and cosine first. It's like on this one, it's not the best strategy, but I'm just kind of showing you why it's not. Cotangent squared plus 1. There isn't a quotient, so there isn't a denominator. I could leave it like that, but we can do one better. That's actually a Pythagorean identity. What's cotangent squared plus 1? It's cosecant squared. And that would be like the premier answer there, like that I would want to see. Okay? So one way or another, we're going to get that down to cosecant squared. Okay? All right, let's look at another one. Let's look at, say, well, 58 is a pretty cool one. Okay, secant theta minus 1 times secant theta plus 1. We're asking what that is. Okay, so I would distribute. So I get secant squared theta, secant theta minus secant theta minus 1. So just kind of distribute everything out. All right, and then this cancels. We get secant squared minus 1. Now, you might be saying, okay, well, there's not a quotient, so it's probably fine. It would be better if we could rewrite that if we can. So I might be thinking, okay, that reminds me of a Pythagorean identity, right? So we know up here, I'm just going to kind of write, we know that 1 plus tangent squared is secant squared. So if I think about what this equation means, if I were to subtract 1 from both sides, I know that tangent squared is secant squared minus 1. So the idea is that instead of writing this as secant squared minus 1, I want to write that as tangent squared. Okay? It's one better than what we had before. And that would be our better answer. Okay. All right, let's look at some more. So we've done some where we had to distribute, simplify, use some Pythagorean identities, use some quotient identities. Let's look at, what should we do? Oh, yeah. Okay, let's look at 60. Okay, so cosine plus sine divided by sine. So you may note with this one, it's already in terms of sine and cosine. So what I would do here really is kind of rewrite this. If I have cosine plus sine over sine, that's really cosine divided by sine plus sine divided by sine. So I'm just kind of dividing each term by the sine. And then cosine over sine is actually cotangent, right, by our quotient identity. And sine over sine is 1. What's cotangent theta plus 1? Is that cosecant? No, absolutely not, right? That is not a mistake you want to make. I know that cotangent squared plus 1 is cosecant squared. Cotangent theta plus 1, no identity for that. So for this one, I would just leave it like this. Okay. It's kind of nice to see how much time I got. We're on 17-minute mark at this point. Okay. Yeah. Should we do 62? Let's do 62. Okay. 1 minus sine squared divided by 1 plus cotangent squared. Yeah. Kind of playing by their rules here. We could go through and rewrite that cotangent squared, okay? And in fact, I guess we will try to play by the rules, I guess. So I've got 1 minus sine squared, and then cotangent is 1 cosine over sine, so cotangent squared is cosine squared over sine squared. Okay. Now, kind of want to simplify, continue to simplify this. Right now, it doesn't look so great. In order to combine these two fractions down here, I would have to get a common denominator. So this left-hand fraction, I would have to multiply by sine squared over sine squared, right? So I have 1 minus sine squared, and then I multiply by sine squared over sine squared on that left-hand fraction, so I get something like this. Now, at this point, I'm thinking, this went from looking really hopeless to actually looking pretty good. So I got the 1 minus sine squared, and then I combine the two fractions in the denominator here. So this is sine squared plus cosine squared over sine squared.